All right, this is lesson 48 through 50. Start with 48. 48 is about what we call polynomials. If you remember what a polynomial is, it is something where you've got, I'm going to use X today. It could be Y or any other letter. That's a polynomial. That's a polynomial. That's a polynomial. Those are polynomials. These are all polynomials. Anything with an x in it, or an x squared, or an x to the fourth, or an x to the fifth, and the combination where you're adding those up. Those are polynomials. Okay, poly means many, and nomials just means name or thingy. So polynomials are just generally speaking, mostly you'll see them like this. Okay, so what do we do with that? Well, you can add them, you can subtract them, you can multiply, and you can divide them. And that's primarily what this week's stuff is about. So add, subtract, multiply, and divide. So let's start with adding and subtracting. So if I have, let's start a simple thing. If I have a negative 5x plus 3 plus 7x, that's a polynomial. When we look at these, we add similar or like terms. So this would be 2x plus 3. And normally when we write polynomials, we write them with the x's and the numbers in this order. So if I have something like 5x to the third plus 2x to the fourth plus 3x squared, that's not typical. I would normally put the 2x to the fourth first, the 5x to the third second, and the 3x to the second third. That's what we call in order of decreasing exponents. These are exponents. This is in order of them decreasing. So that's how we would typically write polynomials. Now, so let's say we have polynomials and we want to make sure that we understand the rules. So I'm going to give you one from your homework. So for example, negative parenthesis. Let's start with 3x to the 5 plus 2x squared. Okay, so what this is means you're saying the opposite of everything inside this parentheses. So this would be negative 3x to the fifth and a negative 2x squared. That's how you have to think of it. I've got a this thingy and a this thingy. They are the opposites of those. Okay, in the same way, let's say you have 3x squared minus 2x minus 4. If I were to say, okay, what's this? Well, that's a negative 3x squared, and then a positive 2x and a positive 4. Again, it's a negative of everything in there. A negative of 3x squared is that. A negative of that is that. A negative or opposite of that is that. So when you see a negative outside of parentheses, negative 4 minus 2x squared, is you're saying basically everything in here is the opposite. Okay, so if you've got that down, then that makes a big difference on you being able to say, can I add and subtract polynomials? Let's go to practice problem number 1 on lesson 48, and it looks like this. Negative parentheses 3x to the fifth plus 6x to the fourth minus 7x to the third minus 5 plus x to the fifth minus x to the fourth. Oops, x. Sorry, I wrote that wrong. Minus x to the fourth plus 3x squared minus 2x minus 8. Okay, so you have this big long thing plus this big long thing. When you do that, just remember you can only add similar or like terms and just get rid of the parentheses. So this first one becomes negative 3x to the fifth minus 6x to the fourth plus 7x to the third minus 5 plus x to the fifth minus x to the fourth plus 3x squared minus 2x minus 8. So now we just look. There's an x to the fifth, there's an x to the fifth. So it's negative 2x to the fifth because negative 3 plus 1 is there. This is how I typically do it. Then I go x to the fourth. Do I have any of those? Sure. A negative 6 and a negative 1 is a negative 7. X to the fourth. That's those. Any x to the thirds? Yep, there's a 7 x to the third. Any x squareds? Yep, there's a 3x squared. Any x's? Yep, minus 2x. Any numbers? Sure, minus 13. And so that's how you do it. You basically take your things that are in parentheses, get them out of parentheses, and then combine the like terms. And I do it just like I showed you. I circle them and cross them out as I go. And I start with the biggest one and work my way down till I'm done. It's just systematic, easy enough. That is lesson 48. Okay, so let's go on to new stuff. Lesson 49 is going to be not about adding or subtracting. It's going to be about multiplying. So let's go to that. So let's say I have 3 times x plus 4. Okay, the way I look at this is I say 3 times x, 3x, plus 3 times 4, 12. That's the distributive property. Distributive property. One of the most common things you use in algebra. So if you have a number in front of the parentheses, that just means that times everything inside the parentheses. Okay, so let's say I have 4x times x squared minus 2. It's no different than the one I just did. It's just that times that. 4x times x squared is 4x to the third. And 4x times negative 2 is minus 8x. So that's that. That's how you do it. So if you have a number or a polynomial term in front of parentheses, we distribute that times each piece inside. Okay? So let's move to a little bit more complicated. What if you have something like 3x plus 2 times 2x plus 5? Okay, here is where your brain has to look at this a little different. I'm going to help out by colorizing these, and that should help a little bit. So instead of saying 3x plus 2, I'm going to say, this, parentheses, 3x plus, and I'll pick a different color, and we'll go blue, 2 times 2x plus 5. So here, what you're doing is you're saying 3x times this, okay, 2x plus 5, which is 6x squared plus 15x. Okay, so this times this, 6 squared, and then this times this. There. Okay, then I go to my blue version, and I say 2 times 2x is 4x, and 2 times 5 is 10. So when I'm looking at what is my final answer on this thing, it is 6x squared plus 15 plus 4, which is plus 19x plus 10. So I'm going to do that without all the colors, and hopefully this will make sense to you if I do it again. Okay, so let's say I have 4x plus 5 times 3x minus 2. It's going to be 12x squared, that's 4x times 3x, plus 4x times negative 2 is it's actually plus a negative 8x, plus 5 times 3x is 15x, plus 5 times negative 2 is negative 10. So notice how in my head I said this plus this plus this plus this, even if it was a negative sign. Okay, that really helps. So I have 12x squared. There are no other 12x's. Now I have a negative 8x and a 15x. That's going to be 7x and a negative 10. And that's going to be the answer to that. One more time, and let's take a look at it. Let's go 4x minus 2 times, let's make it even harder, x squared plus x plus 4. Well, how do we do that? Same thing. We use the distributive property. We just say this times this. Well, that's 4x to the third. This times this. So it's plus 4x squared. This times this. That's 4x times 4, which is 16x. Now, negative 2 times this. Well, that's negative 2x squared. Negative 2 times this. That's negative 2x. And negative 2 times this is positive 8. Then I just, look, I have a 4x to the third. That's all those. I have a 4x squared and a negative 2x squared. Just add those, I get 2x squared. That's those. I have a 16x and a negative 2x. That's 14x. And I have an 8. That's the answer to that. So it does not matter how many things we have. We could have 4x squared plus 2x to the fourth plus 3x to the third plus 2x squared plus x minus 7. And you would do the same thing. You would say this times this plus this times this plus this times this plus this times this plus that times that, and then do this one times each one of those things. So you basically take these, distribute, then you take the second ones and distribute. That is lesson 49, is can you do that? Most often you will get with 2 things here and 3 things here. And you will go this times this, this times this, this times this, plus this times this, plus this times this, plus this times this. So that's how those will work on lesson number 49. Now we go to lesson 50. And it's a little bit of terminology on lesson 50. So let's start with being able to name these things a little bit clearer so that we all know what we're talking about. So let's say I have x to the third plus 2xy plus m or something. Okay, what we do is the biggest exponent, that one, is what we look at. So this would be called a third degree polynomial. For x to the fifth plus 2. That's a fifth degree. Okay, got it? So that's a little bit of terminology. Whatever the biggest x is, that's what it is. If you have just x plus 9, this is a, remember, this is like x to the 1th. So this is a first degree. Okay, and then if you look at just 4, we would just call that a number. We don't call it a polynomial if all you have is a number. Okay, and so let's look at what you might do with this particular lesson. For the most part, it's just making sure you understand that. And now we're going to move into graphing again. In other words, so let's say you have a polynomial that has x's and y's in it. Okay, so let me give you a typical example of one that might have x's and y's in it. Y equals 2x plus 4. Okay, if you have x's and y's, and so these are all first degree. This is important. Notice that's a 1, that's a 1. They're first degree, and you have x's and y's. Okay, and there are no xy's. It's just x's, something times x's plus or minus something times y's. This is what we would call a linear equation. This is a linear equation. Okay, let's see if you can identify that a little bit more. So x plus 4 equal y. That's a linear equation. 2x minus 2y equals 7. That's a linear equation. 2x plus 2y equals 0. That's a linear equation. X equals 4. That is a linear equation. Y equals 2. That is a linear equation. If it has x's and y's, or one or the other, and it's first degree, and there's an equal sign to it, and it can have numbers, or it can not have any numbers. 2x equals 4y. That's also, 4y. That's also a linear equation. If it's got x's and y's, or just an x, but they're first degree, it makes it a linear equation. Okay, so now it's a linear equation. You look at the word linear, and you think, what does that mean? Well, linear, that means if you were to draw a graph of this, it's a line. Let me explain that a little bit. So let's say you have a graph. X is usually on that. Y is usually on that. That means if you have something like y equals 3x minus 2, it means I can graph this on this chart. That means is that for every x, so like let's pretend that x was 0. So what's 3 times 0? 0. What's y? Well, y equals then negative 2. Let's pretend x is 1. Well, 3 times 1 is 1. Or 3 times 1 is 3. And minus 2 is 1. Let's say x is 2. 3 times 2 is 6. 6 minus 2 is 4. And you'll notice that when I put in different x's, I get different y's. If I were to take a graph like this one, and went ahead and graphed them, 0, negative 2, 0 over negative 2, that's a dot, and 1 over 1 up, that's a dot, 2 over 4 up, that's a dot. You'll notice that these dots will form into a line. That's why it's called a linear equation. Okay, and depending on what the equation is, that dots are going to be flatter or steeper or straight up and down or straight sideways. Those are all different kinds of linear equations. So what this lesson is all about is just getting you kind of on this track. So let's look at this, and it's a fairly simple in the sense that there's only one level of difficulty to it. Is if I have a graph and I have a point, let's say 3, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, x is on the flat, y is going straight up and down. 3, 3 is 1, 2, 3 over, 1, 2, 3 up, 3 over, 3 up. That's that. So this is when we say graph this line, or graph this point. If I say graph negative 2, 4, well, I would go x's are first, y is second. So x is negative 2 up 4. So that's that dot. Okay, so 2, 4, that's that one. 3, 3, that's that one. So these are positive over here. So this is going to be 1, 2, 3. This is going to be 1, 2, 3, 4. This is going to be negative 1, negative 2, negative 3, negative 4. And on the downwards, it's negative 1, negative 2, negative 3, negative 4, etc. So when we graph things, these numbers are the x-axis. These numbers are the y-axis. Okay, that's all you're going to have to do for this particular lesson. We will do quite a bit more of graphing lines equations with lesson 51. But lesson 50 is graph dots. Not a big deal. I will see you next time.